So for this section 2.4, we are just going to go right to the assignment, and I'm going to go through some of these with you, but you are responsible for finishing the rest of these on your own. So in numbers 1, 2, and 3, it says match the inequality with its graph. You simply have to solve each one of these inequalities and then match it with the graph. So let's go through graphing inequalities. So that's what you're going to be doing in 4 through 9. You're solving and graphing. So I'm going to go through, let's start with number 4. On number 4, the inequality that's given to you is 6 is less than negative 5t minus 4. So to undo the subtraction, we're trying to get that term with t in it by itself. To undo the subtraction, you add 4 to both sides of the inequality. These 4's will cancel. We get 10 is less than negative 5t. And to undo the multiplication, we need to divide off the negative 5. But again, because we are multiplying, or in this case, dividing by a negative, we need to flip the inequality symbol. So our solution becomes 10 divided by negative 5 is negative 2, is greater than negative 5's cancel, and t is by itself. So ultimately, to write my solution, I'd say the set of t such that t is, the inequality symbol is opening away from the t, so it needs to open away from t here, is less than negative 2. And now it says we have to graph the solution. So how do we graph one of these? Well, we need a two-dimensional graph because there's only one variable. Excuse me, what am I saying? We need a one-dimensional graph because there's only one variable. If there was two variables like an x and a y, then we need to use 2 dimensions. So there's only one variable, so we need a one-dimensional graph. So just a number line. So on the number line, I'm going to put a few values. I'm going to put negative 2 in the middle, and then I'm going to go, and the negatives right now, so as I go to the right, I'm getting closer to 0, so there's negative 1. As I go to the left, I get farther from 0. I need to put my boundary point at this value, at negative 2. So hopefully this starts to bring back some memories. You put the boundary point at that value of negative 2, and you ask yourself, do you have to fill in that boundary point or not? So you only fill it in if negative 2 is a solution, because we shade where our solutions exist. So is negative 2 a solution to this inequality? So if you plug in negative 2, is negative 2 less than itself? Is negative 2 less than negative 2? And the answer to that is no. So we don't want to shade this in because it's not a solution. So now we need the numbers that are less than negative 2. So which side of this number line, which side of the negative 2 has numbers that are less than negative 2, and that's the ones to the left of negative 2. You could also plug in one of these values. So let's see, you plug in negative 3, and you just see, is negative 3 less than negative 2? So you substitute negative 3 in for t, and you'd say, is this a true statement? Is negative 3 less than negative 2? And yes, it is. So I need to shade that solution. So all my solutions exist on the left side of negative 2. And I put an arrow because anything smaller than negative 3 is obviously smaller than negative 2, or less than negative 2. If you were to test out this value over here and you tried to say, is negative 1 less than negative 2, that's a false statement. That is not less than negative 2. Negative 1 is not less than negative 2. So I wouldn't shade it. And then I could say the same argument that, okay, then I must need to shade the other side. So you really only need to test out one value if you decide to test out a value. All right, let's try one more. Let's go to one of these more complex ones. How about number, let's go with number 15. All right, so on number 15, it is 6 times the quantity, 1/3 d, plus 4, is greater than 2 times the quantity, d plus 12. Okay, so on this one, I see that I've got a value outside of parentheses. Same thing here, a value outside the parentheses. My variable is stuck inside those parentheses on both sides. So what I'm going to do is distribute. I'm going to distribute the 6, and I'm going to distribute the 2. When I distribute the 6 times 1/3 d, that's the same thing as 6 over 1. So we'd multiply the fraction straight across. So 6 times 1 is 6, over 1 times 3 is 3. So this is really just 6 over 3. 6 over 3 is 2. So we have 2d plus 6 times 4 is 24. It's greater than 2 times d is 2d plus 2 times 12 is 24. Now I need to try to get all of my variables onto one side of this inequality. So I need to subtract 2d from both sides, and then Those are going to cancel on both sides. So I really wanted to take a look at this problem because what happens is I get 24 is greater than 24. Is 24 greater than itself? And the answer to that is no. If there was an equal sign, then the answer would be yes, because it'd be equal to 24. So if it was 24 is greater than or equal to 24, it would be true. But in this case, there's no equal to. It's just greater than, which is false. 24 is not greater than 24. So on number 15, I'm going to say no solution. No solution. So on this one, no matter what you try to plug in for D, you could try to plug in a 1, a 2, a 20, a negative 20. You can try to plug in anything you want, but what's going to happen is it's always going to cancel out on both sides, and you're always going to get a number is greater than itself, which is always false. Therefore, there is no solution. All right, let's start to take a look at 16. I don't want to do the whole thing for you, but let's start to take a look at the word problem. So on number 16, I'm not doing it all, but let's take a look. It says you must maintain a minimum balance of $50. So minimum of $50 in your account. I'm just taking out some notes as I read this. You currently have a balance of $280. Currently, our current balance is $280. All right. It says, Part A, write and solve an inequality that represents how many $20 bills you can withdraw from the account without going below the minimum balance. How many $20 bills you can withdraw. So right here, it says you must maintain that minimum balance of 50. So how many $20 bills can you take out from 280 without going below this balance of 50? And it does say write and solve the inequality. So to write an inequality for this one, this is the part that I'm going to give you. The rest of this problem will be up to you. But it says the current amount we have is $280. We're going to withdraw, meaning we're going to take out a bunch of $20 bills. So we're going to lose, I'm going to subtract $20 bills. But it's not just one $20 bill. We're going to keep doing this over and over and over again. So I need to say minus 20x, where so I'll say x is defined as the number of $20 bills withdrawn. Okay, so I have $280. I'm losing $20 over and over again, so minus 20x. And it says we cannot go below the minimum balance of $50. So this amount, after I keep subtracting off 20s, it still needs to be at least, so greater than or equal to $50. So there is the inequality. There's the first part of part A. So this is part A. You still have to solve. You still have to go on and solve this inequality. So this one is not done yet. You still have to solve the inequality. And then in part B, it says your bank charges an ATM fee of $2.50, which is charged each time you withdraw $20. So that's going to change how much you're taking out right here. It's not just $20 coming out, but now $20 and $2.50 more. So you're going to be losing $22.50 every time you take out that money. So that is essentially answering the first part where you have to write the inequality, then you have to solve it, and you're basically going through the same process. So I'm going to leave the rest of this problem up to you. If you have to reread this a couple of times, that is okay, but please try your best on this assignment. I will go through these, and I'll post a video with that at a later date, but please try to go through these and show me what you can do. All right, thanks.